right, so today's objective is to multiply fraction by fraction, both unit and non-unit fractions. So today, our denominators aren't only going to be 1, they're going to be other numbers as well. And again, we're still doing this visually and numerically. So to review, on Monday, we looked at how to find 1/3 of 1/4, which we know is the same as 1/3 times 1/4. So we know that to start off, we can start 1/4, right? So we shaded in 1/4, and then we needed to shade in 1/3 of the 1/4. And when we multiplied them, we saw that it was 1/12 because here is one piece that is double shaded and there are 12 total. All right, so let's continue that thinking into today's learning. Problem 1. So 1/3 of 3/5. So we're already starting with a fraction that does not have a 1 as the numerator, but we're still going to be doing the same thing. So here we have 3/5 shaded in, but we need to find 1/3 of that 3/5. So again, if we can kind of look at this for a second vertically, you guys can see that I split up the 3/5 into thirds. So I could see 1/3, 2/3, 3/3. Then you're going to shade all the ones that have already been shaded before, because that's the part that exists. So we're not shading in these blank ones. And so let me put that back where it was. But if we shade in that 1/3, now we have to see how much is that. So how many pieces are double shaded? Well, there are 1, 2, 3 double shaded. So that's our numerator. And then our denominator is how many parts there are in total. So 1, 2, 3, 4, 5, 5 and 5, 10, 5, another 5, 15. So 3/15. If we look at it with numbers, we're still getting the same thing, right? 1 times 3 is 3. 3 times 5 is 15. We have 3 out of the 15 shaded. All right, problem 2. So problem 2 is 1/3 times 3/4. Okay, gonna start off with my 1/3. Again, does not matter what fraction you start off with. I'm gonna start off as 1/3. That's shaded in green. Now I need to split up in fourths. So then the opposite way, I'm gonna divide it into fourths. And then I'm going to shade in 3 of those fourths. So if you look here, here is 1/4, 2/4, 3/4, 4/4. Well, it's times 3/4, so I'm going to have to shade in 3 of those. Remember, only the parts that have already been shaded in before. So now I count how many do I have double shaded? 3. How many are there in total? 12. And then we can check our work by doing it mathematically as well. So 1/3 times 3/4. Go ahead and multiply the numerators. You'll get 3. Multiply the denominators, and you'll get 12. All right, and we can kind of check that, yeah, our work here goes with this. You can kind of check yourself there because your area models and the numbers should match up. All right, problem 3. 2/3 times 3/4. I went ahead and started with 3/4. So we split it up, divided into 4 parts, shaded in 3. Now I need to split it into thirds. So we get to, we have 1/3, 2/3, 3/3, but we need to shade in 2. This time we have a lot more to shade in because what you'll notice is that both of our numerators are greater than 1. So now we have a bunch to shade in here. Same thing though. Let's count how many are double shaded. 1, 2, 3, 4, 5, 6. We got 6 as our numerator. How many do we have in total? 12. For this fraction, you'll notice that 6/12 is also half of the whole thing. So when you go and do it mathematically, 2/3 times 3/4 equals 6/12, that question or that answer can be reduced to 1/2 because 6 is half of 12. So just start looking out for ways that you can reduce the problems. All right, and now to problem 4. For this one, I put challenge because this one we're only going to solve numerically. I believe you guys have seen the pattern. So for this one, 3/7 times 7/9, You're going to multiply the numerators. 3 times 7 is 21. 7 times 9 is 63. But that can be reduced. So here's the extra challenging part for those of you who have been reducing so far. When I do 3 times 7 and 7 times 9, I know this seems like a lot, but the 7 and the 7 can both be divided by 7, right? And that's why I have these ones here. And then we have a 3 and a 9. The 3 can be divided by 3 and we get 1. The 9 can be divided by 3 and we get 3. So when you multiply it, it actually becomes 1 times 1 over 1 times 3, or 1/3. All right, so start looking out for those patterns and where you can reduce. But basically, you guys can be solving using an area model and also numerically. So all that you have left to do today is your exit ticket. The exit ticket is 1/3 times 3/7. Again, you should be solving both visually, so using an area model, and also numerically, like we've been doing with all the other problems. Good job.
Thanks for watching.